this class is focused on the rules of refraction of light through the lens. As we know that there are two types of lenses. One is convex lens and another is concave lens. Now our concern is how light refracts through a convex lens and how it refracts through a concave lens. Let's start. Look at this. Well, first we are talking about convex lens. Let's talk about convex lens. This is a convex lens, and this is, let's say, principal axis, and this is a bisector line which bisect lens into two equal half. Now if a ray of light comes parallel to the principal axis, then it passes through a point called focus of the principal axis after refraction. Yes, this is one rule. This is a rule for convex lens. Now it can be written this way. Look at this. A ray of light parallel to the principal axis of convex lens passes through the focus after refraction. It's very simple. This is a rule. And there's another also. Let's talk about second one. There's second rule also. Let's say number 2. This is a convex lens, and this is bisector line, and this is principal axis, let's say. And if a ray of light passes through this optical center of the lens like this, then it passes straight without deviation. Whether it comes from this side or it comes from this side, whatever is the direction. But if a ray of light passes through the optical center of the convex lens, then it passes straight without bending. This can be written this way. Look at this. A ray passing through the optical center emerges without deviation. Means it passes without deviation. This is second rule for the convex lens. And somewhere another rule is also given. Let's talk about this third rule also, which can be represented this way. Let's say this is a convex lens, and this is a bisector line here, and this is principal axis, and let's say this is focus of this convex lens. Focus lies on both the sides, but we are concerned with this one only. If a ray of light is coming through focus and it falls on the surface of the convex lens, then it refracts being parallel to the principal axis. It's very simple, isn't it? This can be recognized as third rule, and we can say this way: a ray of light coming through the focus when falls on a convex lens, coming through the focus when falls on the convex lens, it refracts being parallel to the principal axis of the lens. This way, there are three basic rules for the refraction of light through a convex lens, and these are these three basic rules. But I want to remove this third one. This one I want to remove. Why I want to remove this third one? Because this third one is actually the reverse of the first. If a ray of light coming parallel to the principal axis, then it passes through focus after refraction. Just opposite of this, if it comes from the focus, if it comes through the focus and incident on the convex lens, then it passes being parallel to the principal axis. It is just the reverse of this. And that's why we are using these two rules while drawing different figures or different diagram of convex lens. Okay, this is about the convex lens. Now I want to talk about concave lens now. Let's talk about concave lens. Concave Okay, there are three rules. Number one, let's say we have a concave lens. This is a concave lens, and this is bisector line which bisect the lens into two equal half, and this is, let's say, principal axis. And if a ray of light comes this way, I mean to say parallel to the principal axis, then what is found? It appears to be diverging from this focus of the lens. Actually, light comes this way and diverges this way, but it appears to be diverged from the focus. This is one of the rule. For concave lens, we can write this way. Look at this. A ray of light parallel to the principal axis of concave lens appears to be diverged from focus after refraction. This is one rule. Now, let's talk about the another one, second rule for this concave lens. Let's say this is concave lens. We have a concave lens, and this is a bisector line, and let's say this is principal axis. Now, if a ray of light passes through the optical center, if a ray of light passes through the optical center, then it passes without deviation. It can come from any side, but if it passes through the optical center, then it passes straight without deviation. There is no any bending. And this can be written like this: a ray of light passing through the optical center emerges without deviation. If it goes through optical center, then without deviation it passes. Now, there's another also. Let's talk about third one also. And in third case also, I want to make a diagram of concave lens. This is concave lens. This is bisector line. This is, let's say, principal axis. Now, this is, let's say, focus. If a ray of light is directed towards the focus, if it is directed towards the focus, then what is seen? A ray of light is, if directed towards the focus of concave lens, then it refracts being parallel to the principal axis this way. It can be written this way. Look at this. A ray of light directed towards the focus of the concave lens refracts being parallel to the principal axis of the lens. This way we can represent three, or we can write three different rules for the refraction of light through concave lens. But we can reject this one, last one, because look at this. This last one is just the reverse of this. I mean to say, this is the reversibility of light. If a ray of light is parallel to the principal axis of concave lens, it appears to be diverged from the focus. In the same way, if just opposite of this, if a light ray directed towards the focus, then it becomes parallel to the principal axis. This is just the opposite of the first one. That's why these two are enough to draw different ray diagram related to concave lens. So, first and second, for convex lens, these two rules are enough to draw all the ray of light, and these two rules are also enough for concave lens to draw different rays of light related to concave lens. Okay, this much for today.